David Smith here with yet one more Flipped Classroom math lesson. 3 tips before we start. First, you can adjust the playback speed to suit you. You can also pause a video at any point and jot down notes or write down questions for our next class. Lastly, you can turn on the captions and read my words on the screen. Today's topic, limits and derivatives. And we've been approaching this, and I've been throwing that vocabulary in on the lessons that's in the lead up to this one. So here what we're going to do is we're just going to restate it, give you some more practice finding that derivative function, and give you some new notation as well. Okay, so from our last lesson, we created a derivative formula that you could use to calculate the slope of a tangent line at any point on a given function. And that's where we didn't plug in a number for x, we just kept x in the algebra, and we worked that complicated algebra on down till we had our derivative function, and then we used that to find the slope of a tangent line anywhere on that function. Okay, so putting that into limit notation, the derivative function, remember f prime of x, is the limit as h approaches 0 of f of x plus h minus f of x over h. This is that different quotient that we came up with when we were looking at the slopes of secant lines. Okay, so that's just sort of a review of what that is, and here's some words for that. F prime of x is the formula for calculating the slope of a tangent line at any point x, f of x, on the function. Okay, so that's a good thing for your notes. Now, there's a little bit more notation that we use. You may have bumped into this. The derivative function, f prime of x, can also be described as dy dx. This might be a more physics kind of approach. Or d dx of f of x. And we've also talked about delta y, delta x. We've also done something like this. Delta y, delta x. And that relates to dy dx. I don't know if it comes from delta or not, but it seems like it could. Okay? Now, I want to review the derivative formula. We got that in our last unit. It was just a little side trip, but it's a very useful trick to check your results. Because remember, we're going to do all this pretty complicated algebra and get to a result. And this rule will help you get to the result very quickly so you can check your work. And no, you're not off the hook for doing all that algebra. That's a really important skill to build, so you're going to need to do that. But you can use this function to check your work when you're done. This is quick and easy. Easy peasy. So this is just f prime of ax to the n. What you do to get the derivative function is you multiply the n that's here by the a, so that's the na x, and then you reduce n by 1. So, for example, f prime of x squared is going to be, we have our a is 1, so we multiply our n by 1, 2x, and we reduce this 2 by 1, so I'm done. I don't need to write the 1. So the derivative of x squared is just 2x. And we actually found that in our last lesson. Okay, so let's use what we know to find the derivative function of a more complicated function. So find the derivative of 3x squared minus 2x. So what I've put up here, here's our general formula for doing that. F prime of x is f of x plus h minus f of x over h. Now we're going to do our plug-in step. This, I think, is probably the most important single step in this process, because if you get this wrong, you're not going to be able to cancel your h's. You're going to have problems later with your algebra. So let's do that. So this is f of x plus h. So the first thing we're going to do is we're going to put x plus h in for x in both those terms. So I'm going to start with a square bracket and go 3 times x plus h squared. So I put x plus h in for x. So this is 3x squared, so this is 3x plus h squared. And then minus 2 times x plus h. So now I have my first term. I have this one. Let's put a square bracket. Now we're just going to subtract f of x. So this is minus f of x. So this is 3x squared minus 2x. And remember to put your parentheses around this term, because this negative is going to apply to that one as well. Otherwise you won't get where you need to go. And then this is all over h. Woohoo! Okay, so let's evaluate these two expressions here, and this is going to create our biggest fraction. This is where it's most demanding to keep everything together. So check this out. I've got an x plus h squared. I'm going to leave the 3 on the outside. So let's start with a square bracket just to make sure we're keeping track of everything. I've got 3 times, this binomial squared is going to be x squared plus 2xh plus h squared. Close my bracket. Now I'm going to distribute my negative 2 on these two terms. So that's going to be minus 2x minus 2h. Close my square bracket. So this is a next step for that. Now I'm just going to distribute my negative on both of those. So I have a minus 3x squared. Now this one's going to go to plus 2x. And all over h. That's the biggest fraction I've written all year long. Now it's going to simplify on down. Deep breath, just stay with it, focus on your algebra. I think you can get there. F prime of x now is going to equal, I'm going to distribute my 3. So I think I'm going to try to lose all my brackets on this. 3x squared plus 6xh plus 3h squared. And then bring my minus 2x, my minus 2h, and then I have my minus 3x squared and my plus 2x, all over h. Hopefully I can keep this all on one board for you. Okay, f prime of x. Now here's where we start doing some fun canceling. I have a plus 3x squared and I have a minus 3x squared. That goes away. I have a minus 2x and a plus 2x. Those go away. What else can I cancel? Looks like nothing, but tell you what, you can take a look right now and know you're on the right track. Remember, we need to cancel our h out. I have an h in each of the remaining terms. So that's going to let me do that. If I didn't, then I need to backtrack into my algebra and find out where I messed up. One possible place that's easy to mess up. If I didn't distribute the negative to that negative 2x, then I would have written negative 2x here, and I wouldn't have been able to cancel these out, and I would have had an x term in here. And there's no h in that. Can't cancel it. So if you wound up with that, then you know there's a mistake further up. And then you just have to backtrack in your algebra, take a look and see what you did. Okay, so let's finish this up. I have 6xh plus, actually, I like to write my squared terms first. So I'm going to have a 3h squared plus 6xh minus 2h all over h. Okay? So, boy, that got much more simple. Okay, so now we can start canceling. I've got an h, an h, an h, and an h. So that's great. We canceled the h out of the bottom, so we can evaluate our limit as h approaches 0. So this is just going to end up being, actually, I don't cancel the h here. I did that before. I canceled the squared there. So we have 3h plus 6x minus 2. So there's our pretty simple function. And it's kind of cool. I mean, these steps are gnarly complicated. And we wind up with something that's actually pretty simple. So let's finish. Let's take the limit as h approaches 0 of 3h plus 6x minus 2. Now as h approaches 0, the h term goes away, and we just have 6x minus 2. So that function now can be used to find the slope of a tangent line to any point on this function. So this is the derivative function. This is f prime of x. So it's really simple. You would just take the x-coordinate of the point for which you want to find the slope of the tangent line. You take that x-coordinate, you plug it in there, super simple algebra, and you would have your slope. Pretty cool. I want to show you one more thing. You've done all this algebra, pretty complicated, easy to make little boo-boos. You want to check it. Here's how you do that. You use this rule. So this is our derivative rule, and you apply this rule to this function. Okay, really quick process. So let's do that. Our first term, ax to the n, 3x squared. You take the n, you multiply it by the a, you get 6x, and you reduce that by 1, which is just x to the 1, so that stays the same. Now we have minus 2 times x to the 1. There's a 1 there, so we multiply the 1 by the minus 2. We have a minus 2, and then we reduce the 1 to a 0. X to the 0 is just 1, so it's just 1 times our minus 2. So there's our derivative function there, using the rule. And guess what? It's the same there. So that's our confirmation. So here's the thing though, don't be disappointed, don't be angry that there's a super easy way to get to this. This process is super important. It's also going to have you practice your algebra chops, which are going to be really helpful for the rest of this year and next year in mathematics. So you really have to stay on the hook for this complicated calculation. Okay, let's do another derivative calculation using this process. So this time we're going to find the derivative of f of x equals the square root of x. And again, I've put up our little derivative formula here. So remember, it's f of x plus h minus f of x over h. Okay? So let's do that. So let's write this as a limit, because that's what we're doing. Limit as h approaches 0 of, now we need to plug in our function. So f of x plus h, f of x is the square root, so f of x plus h is just root of x plus h minus root x, that's just f of x, all over h. So this one looks a little bit less complicated than the last ones, and indeed it is. So now you have to think back. We had a little step when we were rationalizing the numerator. We're going to do that again here to simplify this function so we can cancel our h's out. So what we're going to do is we're going to multiply this by root x plus h plus root x over the same thing, x plus h plus root x. So remember, this thing, no matter how complicated it looks, is just 1. And it has to be 1 so that we don't really change our function. Okay, so I'll make that a time. Okay, so let's multiply this out. So this is a difference of squares. So the result is just going to be the thing, I'm squaring root x plus h, so that just gets rid of the root. I have x plus h on top. If I square root x, it's just x. I'm doing a subtraction, so that's the top. And my bottom, now I could distribute the h on both these terms, but really I'm going to look to cancel that h, so I'm not going to bother with that. It's just going to be h times root x plus h plus root x, like that. Now my top, I have an x and I have a minus x. So this is just going to end up being h over this bottom, which is h times root x plus h plus root x. So now I can do my cancel. That's going to cancel, that's going to cancel. Now when you cancel the top away on a fraction, you are left with a 1. Just remember that. So now we have the limit as h approaches 0 of 1 over root x plus h plus root x. Okay? Now we can take this limit. Yeah, the h is on the bottom, but it's not going to create a divide by 0 problem. So all we do is we just run h to 0, and this is going to be 1 over root x plus root x, which is 1 over 2 root x. That's our derivative formula. So if you want to find the slope of a tangent line to any point on this function, square root of x, you just plug in your x coordinate into this function and you solve it, and that would give you the slope of your tangent line. Okay, let's use the derivative formula to check our work. Remember, f prime of ax to the n is going to be nax to the n minus 1. Now the trick to using a derivative formula in this case is to understand how to write square root as a power. And the square root of x is the same as saying x to the 1/2 power. That's from exponents, something that you've had previously. You just have to know that so that then you can analyze f prime of root x is the same as f prime of x to the 1/2 power. Now that we have a power, we can use our rule there. So this is going to be, take the power, multiply it by the a. So we have an a of 1, so this becomes 1/2 x. Now we subtract 1 from our 1/2, so that's the negative 1/2 power. Now we can simplify this further. Negative powers mean you put the variable underneath the fraction bar. So this is going to be 1/2 times 1 over x to the 1/2, which simplifies further to become 1 over 2. Now x to the 1/2, that's the square root of x. And presto, we got the same result that we got here. Okay? So again, derivative rule, quick check. Make sure you can do this process to find your derivative function. Now that you've watched the video, take a moment to write down some notes or questions or a short summary of the lesson. You can also re-watch portions of the video that you didn't get so well the first time. If you enjoyed the video, please click like. If you'd like to help me grow my YouTube channel, please click subscribe.